Okay, so in the last class, we were going over the probability distribution for the discrete random variable. So we'll go over some more example. So this example is a student goes to the library. The probability that she checks out work of fiction is 0.40. And part B is a work of non-fiction is 0.30. And both fiction and non-fiction is 0.20. What is the probability that the student checks out a work of fiction, non-fiction, or both? So we are given some information. So let's consider the event for fiction is F. So we are given that probability of F is equals to 0.40. So we also have probability of, let's consider the event for non-fiction is NF, which is 0.30, or you can consider A, B, C, yeah, whatever you like. So you can consider A as fiction and B as non-fictional. Yeah. This is just notation. It doesn't matter. So both fiction and non-fiction. So that's mean we have the intersection of F and non-fiction, right? So we have also this information, which is 0.20. Now we have to find the probability of fiction, non-fiction, or both. So that's mean we have to find the probability of F or NF. So we have to find this probability. So from the probability rule, we know the rule for this one, right? So what is the rule for this one? This is probability of F plus probability of the second one, non-fiction, minus probability of the intersection of these two, right? So this is the probability rule for addition, and we know that. So 0.4 plus 0.3 minus 0.2. Then it will be 0.5. Do you have any question? Okay, thank you. So this is the special rule of addition. So we know the rule of for addition. When A and B are not mutually exclusive, then in that case, the probability rule for addition is probability of A plus probability of B minus probability of A intersection B. But in case of mutually exclusive events, this part becomes zero. So if A and B are mutually exclusive, so that's mean A intersection B, this is empty. It doesn't contain any element. So when an event doesn't have any element or any outcome, the probability of occurring that event is zero, right? Because this is impossible event. It will never happen. So the probability of this part will become zero. So that's mean probability of A intersection B will be zero. When A and B are mutually exclusive means they do not have any common outcomes. So if A is this event and B is this one, they do not have any intersection. So that's mean they do not have any common outcome. So in that case, probability of A intersection B is zero. Then the probability rule for addition will become probability of A union B is equals to only probability of A plus probability of B. And we will not have this part. So this part will become zero. So what, and you can also see from here, probability of A or B will be just this one plus this one. So we do not need to subtract anything because we are not adding anything extra. And similarly for three events, if three events are mutually exclusive, so that's mean if we have A, B, C like this, then this is A, this is B, this is C. So we have three mutually exclusive events. In that case, the addition rule will be probability of A plus probability of B plus probability of C. Even if we have more than three events, we'll apply the same rule. So if all the events are mutually exclusive, and here you can see we have A, B, C, and so on, and they are mutually exclusive. So the probability of A or B or C or D or E will be then probability of A plus probability of B plus probability of C plus probability of D, and so on. Okay, so now we'll go over some more examples. A single six-sided die is rolled. What is the probability of rolling a 2 or 5? So if we roll a die, then the possible outcomes will be then the sample space will be then 1, 2, 3, 4, 5, 6. Sorry, it should be curly bracket. And probability of rolling each one is same. And this is 1 over 6, right? Because we have total 6 outcomes. So probability of 1 is 1 over 6. Probability of 2 is also 1 over 6. Probability of 3 is also 1 over 6. And probability of 4 is also 1 over 6. And probability of 5 is also 1 over 6. And probability of 6 is also 1 over 6. So now we have to find the probability of rolling a 2 or 5. So let's consider rolling a 2 is an event and rolling a 5 is another event. And if we roll a 2, we cannot roll a 5 simultaneously, right? Because if you roll because once you can roll just one side. So that's mean if you get 2, you cannot get 5 together. Or if you get 5, you cannot get 2 at the same time. So that's mean they are mutually exclusive event. So we have to find the probability of 2 or probability of 5. So since they are mutually exclusive, this probability will be then probability of 2 plus probability of 5. So we is just 1 over 6 plus 1 over 6. This is 2 over 6. So this is the probability. The second example is a spinner has 4 equal sectors colored yellow, blue, green, and red. So this spinner has 4 colors. What is the probability of landing on red or blue after spinning this spinner? So if you spin this spinner, so what is the probability of landing on red or blue? So landing on each color, the probability is same because it has equal chances. So that's mean probability of yellow is 1 over 4. Probability of blue is also 1 over 4. Probability of green is also 1 over 4. And probability of red is also 1 over 4. Okay, so now we have to find the probability that landing on red or blue. So red or blue. So that's mean since they are mutually exclusive. Why mutually exclusive? Because if the spinner land on blue, it cannot land on red at the same time. And similarly, if it's land on red, it cannot land on blue at the same time. That means they are mutually exclusive. So probability of red plus probability of blue. So that's mean 1 over 4 plus 1 over 4. So is 1/2. Do you have any question? Okay, thank you. Okay, so we have one more examples here. A bag contains 20 balls. 3 are colored red, 6 are colored green, 4 are colored blue, 2 are colored white, and 5 are yellow. One ball is selected at random. So one is selected at random. Find the probabilities of the following events. The ball is either red or green. And part B, the ball is either red or white or blue. Okay, so let's consider all the events. The first event is red. So what is the probability of occurring a red ball or selecting a red ball? So what is the probability? Anyone? What is probability of green and probability of blue and probability of white and probability of yellow? Okay. Okay, 3/20. Anyone else? Thank you. So this is, oh, I'm sorry. This is 3/20. So what is the probability of green? Okay, 6/20. Okay. So what is the probability of blue? 4/20. Yes, because we have 4 blue, so it will be 4/20 or 1/4. Yeah, thank you. And it will be then 2/20, and this one will be 5/20, right? Okay, so let's solve part A. So we have to find the probability either red or green. So how can we calculate this probability? Are they mutually exclusive? So what should be the probability for part A? Anyone? Okay, 9/20. Anyone else? Nine over 20. Yeah. Yes, it should be 9/20, right? Because they are mutually exclusive. Because if we select a red ball, we cannot select a green ball simultaneously, right? Because we are just selecting one ball, just one ball. So that's mean if you select a red ball, you cannot select a green ball at a time. So that's why they are mutually exclusive. So it will be then probability of red plus probability of green. So this is 3/20 plus 6/20, which will be then 9/20. Thank you. And part B, we have to find the probability of red or white or blue. So it will be then probability of red plus probability of white plus probability of blue. So then it will be 3/20 plus white is 2/20 plus blue is 4/20. So it will be then, it's also 9/20, right? Yeah, this is also 9/20. Yeah. Yes, this is 9/20 again. Yeah, thank you. Okay, the next section is section 5.4. This is about discrete random variables and their probability distributions. So till now we discussed random variable and corresponding probability. So we didn't discuss about probability distribution. So now in this section, we'll cover discrete random variables and probability distribution. We already know discrete variables, but we do not know what is discrete random variables. So what is random variable? Random variable is a quantitative variable whose value depends on chance. So that's mean whose value will depend on chance. So if you do an experiment, the value of the random variable will depend on the outcomes you obtain, right? So that's why the value of the random variable depend on the chance. And discrete random variable, a discrete random variable is a random variable whose possible values can be listed. So you know the discrete variable. So the definition of the discrete variable was the value for x, which can be, if the value for x or value for the random variable can be listed, for example, number of siblings in a family, number of newborn babies in a family, so they were our number of students in a class. So those variables were discrete variables. So similarly, if the discrete random variable, if a random variable takes only discrete values, or if the possible values of a random variable can be listed, then it is called discrete random variables. Okay, so for example, here we have, so if we toss a coin, then either we will obtain a head or tail. So if the random variable, if we consider, if sorry, so if x is a random variable and this is the number of tails, it represents number of tails, then if we toss a coin once, or if we flip a coin once, then it will be, the outcome will be head or tail. So if x is the number of tails, then how many tails we have here? We have 0 tail, right? And how many tails we have here? We have just 1 tails. So that's mean the x can take either 0 or 1. Okay, so now the value of x will depend on the outcome we'll obtain after flipping a coin, right? So we can either get head or tail. So the value of x will depend on chance. So that's why it is called random variable. And why it is discrete? Because it has only 2 values and which are discrete, right? So we can list all the values. So the x can take only 0 and 1 in this case, right? X has only 2 values here, 0 and 1. So that's why this is discrete. And similarly, if you throw a die once, then you can obtain either 1, 2, 3, 4, 5, or 6, right? So if x is the score shown on the top face, then the values of x will be 1, 2, 3, 4, 5, 6. So those are the possible values for x. So that's mean we can list all the possible values of x. So that's why this is discrete random variable. We have a few more examples here. The experiment is roll 2 fair dice, and random variable is the sum of the number of dots on the top faces. So if you roll 2 fair dice, then the numbers will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, right? Then similarly 2, 1, 2, 2. That's when first one is 1, second one is 1, first one 1, second one 2, first one 1, second one 3, first one is 1, second one 4, first one 2, second one 5, and first one 1, second one 6. Similarly, we have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2. So we'll have total 36 outcomes. So now the random variable x is sum of the number of dots on the top faces. So that's mean we'll add this number to add these 2 numbers together. So this will be then 2, this will be 3, this will be 4, 5, 5 plus 1 6, and 6 plus 1 is 7. And similarly 2 plus 1 is 3, 2 plus 2 is 4, and so on. And we'll also have 6 1, so 6 plus 1 is 7, and the last number will be 6 6, which will be 12, right, if you add them together. Okay, so here the random variable x is sum of the number of dots on the top pages. So what are the possible values of x? Oh, it's also given here, right? So the possible values of x will be then 2, 3, 4, 5, 6, 7, and up to 12, right? Because the smaller number is 2 and the maximum number is 12. So the numbers for x will be then 2 to 12. So we can list all the possible values. So that's why this is also discrete random variable. So flip a fair coin repeatedly, number of tosses until the coin lands heads. So you will toss or you flip a coin until you get a head. So what are the possible values of x in this case? Number of tosses, right? So if you just do one toss or one flip, you can get hit, right? So one could be a possible value. Or to get head, you might need to flip it twice, right? So two could be a possible value. Or you might need to flip the coin 3 times to get a head, right? Because first 2 times, if you get tail, in the third flip, you can get head, right? So 3 could be a possible value. And then, so now the question is, can x take a 0 in this case? Anyone? Is it possible that that x can take a 0 in this case? No, right? Because this is the number of tosses, not number of heads or number of tail. It is the number of tosses. So the minimum number of flip or number of toss could be 1, right? So that's why it will take 1, 2, 3, 4, 5. And you might need to flip infinite number of times. For example, after 1,000 times, you can get a head. In the first 1,000 time, you didn't get a head, you get all tails. So after 1,000 times, you can get a head. Or maybe after 10,000 time, you can get a head. But in reality, it is not going to happen. I think if it is a fair coin, then for sure you will get a head before 1,000 times or 100 times or 10 times. But is it still possible that in 100 flips or in 1,000 flips you cannot get a head? So that's mean you have to flip the coin more. So that's why x can take values infinite number of times. Okay. So now we'll discuss about probability distribution and probability histogram. So what is probability distribution? So what type of distribution till now we know? So what are the distributions we learned before in chapter 2? Do you remember? Anyone? Do you remember any distribution we learned in chapter 2? Okay, estimate leaf. Yeah, this is also graphical representation. Yeah. So do you remember frequency distribution and relative frequency distribution? Okay. So the frequency distribution, how did we construct frequency distribution? So we have listed all the possible values here, right? So if x is variable, so we listed all the possible values. And we listed the frequency, right? In the second column. So that was the frequency distribution. And for relative frequency distribution, we have listed the values of x in the first column. Then we have listed the relative frequency in the second column, right? Yeah, relative frequency distribution. Yeah, that's correct. So similarly, the probability distribution is we'll list all the possible values of the random variable in one column. And in the second column, we'll list corresponding probabilities, right? Because this is probability distribution. So if x is a random variable and it takes only 2 numbers, head and tail, so probability of x equals to 0, it has some probability, and probability of x equals to 1, it also has some probability, right? So if we list all the values of x, so here x is 0 and 1, and if it is a fair coin, then this will be half, this will be also half, and we'll list the corresponding probability here. This is called probability distribution. So now based on this, we can construct a histogram for this, similar to the relative frequency or frequency. So we constructed frequency distribution and relative frequency distribution. Similarly, we can construct a histogram for this distribution, probability distribution. This is called probability histogram. So here we have an example. And this example is how many heads when we toss 3 coins. So we have 3 coins. So how many heads we'll have when we toss 3 coins? And X is the number of heads, and this is the random variable. So here the random variable is X, and which is number of heads. So if we toss 3 coins, what are the possible values, possible outcomes? We can get all 3 heads, right? We can get first 2 head and third one is tail. First one head, this is tail, this is head. So we can have 8 possibilities, right? 8 possible outcomes. So now X represents the number of heads. So how many heads we have here? We have 3 heads. So that's why X takes the value 3. And how many heads we have here? We have 2 heads here, right? So that's why X is 2. And we have also 2 heads here. That's why X is 2. We have just 1 head. That's why X is 1. We have 2 heads here. So X is 2. So we have 1 head here, X1. So we have 1 head here, X1. And we do not have any head here. So that's why X is 0. So what are the possible values of X here? The possible values of X are 0, 1, 2, and 3. So what are the corresponding probabilities? So now we'll construct a probability distribution. So we need 2 columns here. The first column is for X, and the second column is probability of X is equal X. Okay, so this is the probability notation for any random variable. Probability of, if X is random variable, then this is capital X, that represents the random variable, and equal small x represents a specific value. So what are the specific values? So we have 0, 1, 2, 3. So this small x represents either 0 or 1 or 2 or 3. And X is the capital X represents the random variable. Okay, so what are the possible values? 0, 1, 2, 3. So what should be the probability corresponding to 0? So what is the probability corresponding to 0? Anyone? Okay, 1 over 8, 1 over 4, 1. Okay, I got 3 different answers. Anyone else? Okay, so when I ask a question, I expect a response from everyone. 1 over 8, 1 over 8. Okay. 1 over 8. Yeah, so I got too many 1 over 8. Yeah. Okay, thank you. So the probability is 1 over 8. Okay, what is the corresponding probability to x equal 1? Anyone? So when x is 1, what is the probability when x is equal 1?
3 over 8.
When x is 1, is it 1 over 8? Or how many ones we have here? We have 3, right? So it will be 3 over 8. Thank you. So this is 3 over 8. And for 2, it's also same, 3 over 8, right? Because we have, how many times we have 3? 1, 2, 3. and total is 8. So this is 3 over 8, and this is 1 over 8. So this is called the probability distribution of x. We have all the possible values of x and their corresponding probability. So this is called the probability distribution. Okay. So now we have another example. Two dice are tossed. X is the sum of the scores on the two dice. So here x is the sum of the scores. So we have added the scores. This is 1. Second one is 1. So it is 2. 1 plus 1, 2. 1 plus 2, 3. So we have all the possible values here. So x can take 2. Okay. So now we will write the probability distribution. So you can write it column wise or row wise. It's fine. X equal x and probability of x equal x. So the possible values are 2, 3, 4, 5, 6, 7, 8, 9, 10, sorry, 11, and 12. Okay, now we have to write the corresponding probability. So total, we have to, how many outcomes we have? We have total 36. So 2, how many times we have 2? We have just 1. So it will be 1 over 36, right? And for 3, how many times we have 3? 1, 2. So it will be 2 over 36. And for 4, how many times we have 4? We have 4 times. So, sorry, 3 times. So it will be 3 over 36. And for 5, how many times we have 5? 4 times. So it will be then 4 over 36. And we have 6, 5 times. So it will be 5 over 36. And similarly, we have 7, 6 times. So it will be 6 over 36, and so on. The next one will be again 5 over 36, 4 over 36, 3 over 36, 2 over 36, 1 over 36. Okay, so now the question is, if we add all the probabilities, so if you add all the probabilities, then what will be the result? If you add all the probabilities together, anyone? Without adding. Yes, it will be 1 because it is the total probability, right? So the total probability is always 1. Even if you, without doing any calculation, you can tell that this is 1 because this is the total probability. And we know that this is probability distribution, and these are the all possible values of x. So that's mean if you add the corresponding probabilities, it will be always 1. If it is not 1, then it is not a probability distribution. Okay, thank you. So now we have one more example. What is the probability that sum of the score is 5, 6, 7, or 8? So now we have to find the probability sum of the score is either 5 or 6 or 7 or 8. So this is mutually exclusive, right? Because if you get a 5, you cannot get a 6. If you get a 6, you cannot get a 7 at a time. So that's why they are mutually exclusive. The probability will be 5, 6 plus probability of 7 plus probability of 8. Or you can also write this one as actually probability of x is equal 5, 6, 7, or 8. And here you can write x is equal 5, x equal 6, x equal 7, and x equal 8. So what is the probability when x is 5? When x is 5, this is 4 over 36. Okay, when x is 5, this is 4 over 36. And when x is 6, this is 5 over 36. And when x is 7, this is 6 over 36. And when x is 8, this is 5 over 36. Okay, so now the question is, why do we need the probability distribution? So if you have the probability distribution, you can calculate the probability for any event. So from the table, we are taking all these numbers, right? Because we have the probability distribution. So from there, we know the probability corresponding to each number. So that's mean if you have the probability distribution, you can find the probability for any event. So now the total probability will be then 20 over 36. Or if you simplify this one, then it will be 5 over 9. Okay, we have some more examples. Two coins are tossed. If y represents the number of tails, so what is the probability of y is equal 1? And if y represents the number of tails, what is the probability y less than equal 1? Okay, so let's try it and let me know the results. What do you get from here? So find the probability y equal 1 and find the probability y less than equal 1. Okay, so I'm giving you 2 minutes. Here the random variable is y, and y represents the number of tails. So what are the possible values of x? Sorry, possible values of y? Number of tails. If you toss a coin twice, then you can have 1 tail, 0 tail, 1 tail, and 2 tails. So these are the possible values of y. Now find the corresponding probability. Okay. Okay, so when you are giving me the answer, just consider this one as part A, this one part B. So when you give me the answer, give the answer for A and B separately. Okay. Okay. A is 1, B is 2. Okay. Okay, so most of you got one answer for part A is 1 and part B is 2. Okay, so now the question is it possible that the probability could be 2? We know that the maximum probability is 1, right? So the probability can never be greater than 1. And we know that. But in your answer, you said the probability for part B is 2. Okay, so I'm actually asking about the probability, not the number of outcomes. I'm asking about the probability. I think you are giving me the number of outcomes, right? But I am asking about the probability. Okay, try again and let me know the answer. So probability of y is equal 1. So when the value of y is 1, what is the probability? And here probability of y less than equal 1. So how many numbers we have for y which are less than equal 1? We have 0 and 1. So that's mean basically we'll be finding probability for y equal 0 plus y equal 1. So you'll be finding these two probability and add them together for part B. Okay, so now let me know the answer. Okay, so 1 over 4 and half. So what are the possible outcomes? Possible outcomes are H, 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 T, TH, and TT, right? So X is 0 means no tail. So that's mean this one. X, oh sorry, Y0. Y1 means this one and this one. And Y2 means this one. Okay. So how many zeros we have? We have just 1 0, right? So it will be 1 over 8. And how many? Sorry, 1 over 4. This will be 1 over 4. And this one will be 2 over 4 or half. And this one will be also 1 over 4. Okay, so let me check your answers. 1 over 4 and half. Okay. And I got also a few more answers. 0.25 and 0.5. Okay. Yeah, both are tail. Yeah, this will be 1 over 4. That's correct. HT or TA is 2 over 4. That's correct. Yeah, that's correct. Okay, so then for A, oh, I'm sorry. For A, probability of y is equal 1. So what is the probability when y1? 2 over 4. So that's mean this is half, right? 2 over 4. This one will be half. Okay, for part B, y less than equal 1. So less than equal 1. So how many numbers we have less than equal 1? 0 and 1. You will add them together. So that's mean probability of y equals to 0 plus probability of y equal 1. So this will be then 1 over 4 plus 2 over 4. So that will be then 3 over 4. So answer for part A is 1/2 and part B is 3 over 4. Yes, part B is 3 over 4. That's correct. Is it clear now? Okay, so y plus 2 over 4. Yeah. So let's see here. Y less than equal 1. So what are the values which are less than equal 1? 0 and 1, right? So probability of y equals 0 plus probability of y equal 1. So y equals 0, the probability is 1 over 4, this one. And y equal 1 is 2 over 4. So that's why we are adding 2 over 4. So is that answer your question? Okay, thank you. Actually, I am showing you more examples because I want to make sure that you understand everything clearly. So if you do not understand especially the probability problem, they're really confusing. Yeah. So the more examples you will go over, you will learn more actually. So it will be more clear to you. So we have one more example here. First die and second die, two tetrahedral dies. Tetrahedral means each die has 4 sides. So and they're thrown and their scores added together. So if you throw 2 tetrahedral die, then the outcomes will be 1 1, 1 2, 1 3, 1 4. Then 2 1, 2 2, 2 3, 2 4, 3 1, 3 2, 3 3, 3 4, and 4 1, 4 2, 4 3, 4 4. Okay, so those are the possible outcomes. So now X is the sum of the scores on the 2 dice. So X represents the sum of the scores. So if we add them together, so it will be 1. If you add this one, it will be 3. Sorry, it will be 2 if you add them together. And if you add this number, it will be also 3, right? So if you add these two numbers, this one will be 4, this one will be also 4, this one will be also 4, right? This one will be 5, 5, 5, 5. 4 plus 2 is 6, 6, 6, 7, 7, and this is 8. So what are the possible values of X? Anyone? You can see it here, right? The minimum is 2, then 3, 4, 5, 6, 7, 8. So these are the possible values of X. Okay, so now what is the probability? Now we have to find the probability X is equal 6. Okay, so let's construct the probability distribution first. Then it will be easier to calculate all the probabilities. So let's construct the probability distribution. So write down the possible values: 2, 3, 4, 5, 6, 7, 8. So what are the corresponding probability? Corresponding to 2, this is 1 over, we have total 16, 1 over 16. Then okay. Then corresponding to 3, this is 2 over 16. This is 3 over 16. This is 4 over 16. 3 over 16. 2 over 16, 1 over 16. So this is the probability distribution. So now we have to find the probability. So part A, find probability of X is equal 6. Part B, probability of X greater than 7. Part C, probability of X less than equal to plus, or we can say or, sorry, X. So X greater than 6. Okay, find these 3 probabilities, A, B, C. Yeah, so I'm giving you 3 minutes for this one. Find probability of X equals 6, X greater than 7, and last one is X less than equal to or X greater than 7. So let me write it clearly. X less than equal to or X greater than 6. Yeah. So find these 3 probabilities. So I'm giving you 3 minutes. Okay, so A is 3 over 16, 1 over 16, 4 over 16. Okay, so A is, so I got two answers, three answer, yeah. 1 over 16, 1 over 4, okay. Okay, yeah, so I got answer from 1, 2, 3, 4, 5, 5, 6, yes, 6, 7 from 7%. Anyone else? So I got 9 answer, 10. Yeah, and all the answers are same. Okay, thank you. So most of you actually, most of you have same answer. Let me check. So when x equals 6, yeah, it is straightforward, because when x is 6, this is 3 over 16. So you do not need to calculate it. When x greater than 7, so that's mean the numbers which are greater than 7, above 7. So we have just one number, 8, which is 1 over 16. That's correct. And here x less than equal 2 and or x greater than 6. So how many numbers we have in this case? X less than equal to just this number, or x greater than 6. X greater than 6 means 7, 8. So that's mean 1 plus this one. So 2 plus 1. So 4 over 16. So this is 4 over, sorry, 16. So that's mean 1 over 4. Yeah, that's correct answer. Yeah, I think most of you got correct answer. Thank you. Okay, so we have one more example. Two tetrahedral dice are thrown and their scores added together, and x is the sum of the score. Actually, is the same example. Now we have to find the probability between 3 and 5. So that's mean it will be actually x equal 3 plus probability of x is equal 4 plus probability of x is equal 5. So if you go to the previous table, then for 3, 4, 5, this is 2 over 16, 3 over 16, and 4 over 16. So it will be 2 over 16 plus 3 over 16 plus 4 over 16. So it will be then 9 over 16. So this is the probability. Okay. So now we are given a probability distribution and its corresponding histogram. So this is the example for a number of siblings where x is 0, 1, 2, 3, 4, and their corresponding probabilities are given. So we have the possible values and their corresponding probability. So the total probability 1. Okay, so if you are asked to check whether, so if you are given this table and if you are asked to check whether this is a probability distribution or not, how do you check? You will add, first you will check all the probabilities are non-negative. That's mean either 0 or positive, and between 0 and 1. So if they are not between 0 and 1, they are not, it is not a probability distribution. Or if you have a negative number here, for example, this number is negative, then this is not a probability distribution, because the probability is always positive and it is between 0 and 1, 0, 1 inclusive. And if this condition satisfied, then the third condition is the total probability cannot be greater than 1. Sorry, the total probability is 1. So if you add them together, it will be always 1. So if these three conditions satisfy, then this table is a probability distribution table, or probability distribution. Okay, so now we have the histogram corresponding to this table. For 0, the probability is 0.2. So the height of this bar will be 0.2. 1, this is 0.425. So height of this one is 0.425. For 2, this is 0.275. So height of this bar is 0.275. And for 3, this is 0.075. So height of this bar is 0.075. So this is called the probability histogram, because this is the histogram corresponding to the probability distribution. And looking at this, you can get the probability, or you can also have the idea about the shape of the distribution. So if you add this, the middle midpoint together, that will give you the shape of the distribution. This is actually slightly right skewed distribution. Okay, so the sum of the probabilities of a discrete random variable. So we already discussed this one. X is equal X, and this is probability of X is equal X, and the total probability is 1. We already know that the sum of the probability for discrete random variable is always equal 1. So the interpretation of a probability distribution. So in a large number of independent observations of random variable X, the proportion of time is possible values occurs will approximately the probability distribution of X. So if you consider a large number of independent observations of a random variable, and if you calculate the proportion for corresponding to each value and construct the distribution, then the distribution will be approximately the probability distribution. Or equivalently, you can say the proportion histogram will approximate the probability histogram. That means you already know how to construct the relative frequency distribution or relative frequency histogram. Actually, the relative frequency histogram is approximately the probability histogram for the random variable X. So you can see that here, histogram of proportion for the number of hairs. So here we did the experiment 1,000 times, and we construct the frequency, relative frequency histogram. So if you do the experiment a large number of times, and if you calculate the proportion corresponding to each outcomes, that will give you the probability histogram or probability distribution. So if you toss a coin 1,000 times or maybe 10,000 times, and if you calculate the proportion for head and proportion for tail, that will give you the probability distribution or probability histogram. And similarly, if you toss a coin twice, so here 3 tosses obtained in 3 tosses. That means if you toss a coin 3 times, you will have 3 possible, the possible outcomes will be then 0, 1, 2, and 3. So you can have maximum 3 number of heads. So if you do this experiment 1,000 times or 10,000 times, and if you calculate the proportion for 0, that's mean no head, proportion for 1, that's mean 1 head, and proportion for 2, that's mean 2 head, and proportion for 3, that's mean obtaining 3 heads. If you calculate the proportion, then you will see that that will give you the probability distribution, because we already know the probability corresponding to 0 is 1/8, and corresponding to 3 is also 1/8, and this is 3/8, 3/8. And you will actually obtain the similar proportion if you do the experiment maybe 1,000 times or 10,000 times or maybe 100,000 times. Okay. So the next section is about the mean and standard deviation of a discrete random variable. So we already know how to calculate the mean and standard deviation for a random variable, but we do not know how to calculate the mean and standard deviation of a discrete random variable. So we know for a variable how to calculate the mean and variance or standard deviation for a variable, but we do not know how to calculate the mean and standard deviation for a discrete random variable. Okay, so since X is a discrete random variable, so that means we know all the possible values of X and its corresponding probability. So we know the possible values of X And we also know probability of x is equal x. If x is a random variable, then the mean, the expected value, that's mean the population mean, the expected value is denoted by E of x. And this is also the population mean. So that's mean the expected value means the value we expect for x. So that is the expected value, the average value. And which is the population average or population mean, and is denoted by mu. So mu is equals to expected value of x, which is the population mean. So how do we calculate the expected value? This is actually the multiply. So first you will multiply each value of x and its corresponding probability. Then you will add them together. So that will give you the expected value. So this is the definition of the expected value, or mu. Summation of x times probability of x is equal x. So that's mean you are multiplying the probability with each value of x, and then you are adding them together. That will give you the expected value. So that's mean if you do the experiment a large number of times, and if the random variable is x, then the average value of the observation is equal to the expected value of x, or e. So here you can see graph showing the average number of busy tellers versus the number of observations for two simulations of 100 observations. Okay, so here you can see when if you do the experiment 10 times, this is the corresponding expected value, and when you do 20 times, this is the expected value, and when you do 30 times, and when you do the 100 times, then you can see that at first when the number of observation is not large, then it's actually fluctuate, it varies like this, and when you increase the number of observations, then it's become flat line. So that's mean when you have large number of, you do the experiment large number of times, then it will the expected value will be close to the average value for that random variable. You will have a stable number. Okay, a standard deviation of a discrete random variable. So how do we calculate the standard deviation of a discrete random variable? So from the probability distribution, we know the values of x and probability of x equals x. So the standard deviation is, or variance is, variance of x is summation of x minus mu square. So that's mean you will calculate the deviation of x from the mean. So first you will calculate the mean, and then you will take the difference of each value from the mean and square it, then multiply with the corresponding probability, then add them together. That is the variance of x. And what is the standard deviation? We already know that standard deviation is the square root of the variance. So if you take the square root of the variance, that will be the standard deviation sigma. So that is a square root of this one. Okay, so we'll go over some example, then it will be more clear to you. So let's consider this example. Tossing a single unfair die. So this is not a fair die. So for a fair die, we know the corresponding probability. Corresponding probability for each possible outcomes is 1/6 if it is a fair die. Right? For 1, it will be 1/6. For 2, it will be 1/6, and so on. But this is an unfair die. So that's why we have different probabilities. Corresponding to 1, this is 0.1. Corresponding to, actually, if you roll this die, most of the time you will get 6 because the corresponding probability is 0.5. So that's mean if you roll this die 10 times, you expect to get 6 at least 5 times. And if you roll this die 100 times, you expect to get 6 maybe 50 times, right? Because the probability is 0.5 for 6. So most of the time you will obtain a 6, right? Because the probability is 0.5. So this is an unfair die. So now we'll calculate the expected value of x. So what is the expected value of x, which is generated by mu? And we know that this is summation of x times probability of x is equal x. Okay, so that's mean first you will multiply each number and their corresponding probabilities. So you can construct a table, but you do not need to, but if you want, you can do it. So this is x, this is probability of x equals to x, and this is x times probability. So that's when we are multiplying here. So we have 1, 2, 3, 4, 5, 6. And here we have probability 0.1, 0.1, 0.1, 0.1, 0.1, and 0.5. So now if you multiply them together, then it will be 0.1, it will be 0.2, this one will be 0.3, 0.4, 0.5, and this one will be 3. Okay, so now you will add them together. So if you add them together, then it will be 0.1 plus 0.2, 0.3 plus 0.3, 0.6 plus 0.4 is 1. So it will be actually 4.5. So if you add them together, it will be 4.5. So the expected value of x is 4.5. So that's mean if you roll this die 100 times, and if you take the average of the outcomes, then the average will be close to 4.5. Yeah. Or you can also do it here. So you can also calculate it here. The first value of x is 1 times the corresponding probability, that's been 0.1, plus 2 times 0.1, plus 3 times 0.1, plus 4 times 0.1, plus 5 times 0.1, plus 6 times 0.1. Sorry, 0.5. The probability for this one is 0.5. So then it will be 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5 plus 3, and which is 4.5. So this is the expected value. So is it clear? Do you have any question? Any question? Okay, thank you. So now we calculate the variance of x. So how do we calculate the variance of x? So we know that variance of x is sigma of x squared times p. P is the probability and x is the corresponding value, minus mu squared. We already know the value of mu. Mu is 4.5. So now you need to just calculate this one, sigma of x squared times p. That's mean first you will calculate x squared and multiply with p, then you will add them together. That will give you this number minus 4.5 squared. Then you will get the variance. Okay, so a random variable x can take only 2 values. So we have one more example here, and the values are 1 and 2, and we have the corresponding probability. So that's mean we have x, sorry, we have probability. Okay, so this is x equal x. So this is 1 and 2. So we have just 2 numbers, and this is probability of x is equal x. So this is 0.8 and this is 0.2. So now we have to find the expected value of x. So expected value of x is summation of x times probability of x. So that's mean 1 times 0.8 plus 2 times 0.2. So then it will be 0.8 plus 0.4. So that's mean this is 1.2. Or you can multiply here. If you multiply here, then it will be 0.1, 0.8. If you multiply this one, then it will be 0.4. If you add them together, then it will be 1.2. So that is the expected value, x times p. Okay, so now we'll calculate the variance for the same example. So if you want to calculate the variance, first you need the expected value. So this is our x. This is our p of x, 1, 2, 0.8, 0.2. So we already know mu from the previous example, which is 1.2. And we know that the variance of x is summation of x times p of x minus mu square. So we know mu, but we do not know this part, right? Sorry, this is x squared times p. So if you take the x square, then it will be 1, and 2 squared is 4. Now we will multiply x squared with p. So 1 times, sorry, this is x squared is 1, and this is 0.8. So if you multiply these two, this will be 0.8. So what will be the value for next one? Anyone? X squared times p. What is the next value? Anyone?
0.8.
Yeah, 0.8, because yeah, not 1.6. Yeah, the total is 1.6. That's correct. The total is 1.6. Yeah, but if you multiply these two, then it will be 0.8. Yeah, but the total is, yes, total is 1.6. So this is 1.6 minus 1.2 square. So 1.2 square is 1.6 minus 1.44. So 1.6. So it will be the 0.16. So the variance is 0.16. So now what is the standard deviation? Standard deviation sigma is a square root of variance of x. So the standard deviation, this is the standard deviation, and this is variance. So standard deviation is a square root of 0.16, and which is 0.4. So this is the standard deviation. So now we'll go over one more example. And this is the last example for today. We have two pair tetrahedral dies, and we thrown these two dies, and their scores added together. And x is the sum of the scores on the two dies. What is the expected value of x? So we already know the probability distribution for this x. So what are the possible values of x? In this case, the possible values are 2 to 8, right? If you go back to the previous example, we had this example, right? We constructed the probability distribution for this one. Yes. So 2 to 8. And we had the corresponding probabilities, right? The possible values are, in this case, 2 to 8. So that's mean 2, 3, 4, 5, 6, 7, 8. And it was 1 over 16, 2 over 16, 3 over 16, 4 over 16, 3/16. So 2/16 and 1/16. So this is our corresponding probability. So now we have to find the expected value of x. The expected value of x is summation of x times probability of x is equals to x. So now we have to multiply these two numbers, right? X times p. So if you multiply these two, then it will be, okay, so the first one is 2/16. That means 0.125. And if you multiply this one, then it will be 3 times 2/16, right? Then 6/16, which will be 0.375. Do you have any question? Okay. So if you do not have any question, please mute your microphone. Okay, then next one is 4 times 3/16. So that's mean 12/16, 0.75. Then this one is 1.25. Then 18/16. Then it will be 1.125. Then next one will be 875. Then 8 times 1/16. So that's mean 8/16. So which will be 0.5. Yeah. So now if we add them together, then it will be 5 plus 1.125 plus 1.25 plus 0.75 plus 0.375 plus 0.125. So it will be actually 5. So the expected value is 5. Yeah, you should also check the calculation. Yeah. So now we have the expected value. So if you want to calculate the variance, then you need to construct another two columns. The variance is summation of x squared equals to x minus mu squared. Mu is 5 here. Okay, so I will stop here, and this is all for today. Thank you. And if you have any question, you can ask me.